You can always tell a CPM problem, critical path management, because you have task information, precedence information, duration information, and nothing else. This scenario is a classic example of that. Consider the following project management problem: tasks, precedence information, duration, nothing else. All right, now what are the questions? What is the expected completion time of this project? In a CPM problem, in order to determine the expected completion time of the project, we're going to write, why in the no frame is there this big space under that one short question? We have to draw the network. We have to draw the network. Now, ideally, you should draw in pencil because you might have to erase. So I will switch to that. But at any rate, drawing a network, the first thing to do is draw the starting node. Okay, it's nothing more than just a label that represents getting started on this project, whatever it is. The start is here. All right, what do you do next? Look at the data, look for any task that does not have any immediate predecessors. Well, there's 3. Okay, draw them. Kind of a flag-shaped rectangle is what's convenient. Put the label up in the upper left-hand corner. There's A. It didn't have any immediate predecessors. There's B. It didn't have any immediate predecessors. And here's C. It didn't have any immediate predecessors. Why am I drawing there? Because, equally important, the connections. If you're at the start, you could start on any one of them. All right, now next step. Let's start adding tasks to this network. I noticed that D has A as an immediate predecessor. Draw that fact. This could represent D. Once you're done with A, you can proceed on to D. That's what that means. Okay, what about, E? E has B and D, meaning you have to finish B and you have to finish D before you can start E. So I'm thinking a good place for it might be like right here, kind of near them, because you have to finish D and you have to finish B before you can go on and work on E. Okay, and then F has D. All right, F has just D. So why don't we put it here? When you are finished with D, you can go on and do F. Now I've exhausted the list, right? Which is good because the network is finished when all the tasks are on the network. But the network is not really finished until, just as it has one start, it really needs one finish. Okay, it needs a label or a node that represents this is it. We're done with the whole project at this point. So I want to draw that. Label it. This is the finish. Now, this is important. What actually gets connected to this? You want to connect, or we call these nodes, right? You want to connect each node. You want to connect every task that has arrows pointing at it, like F, but no arrows leaving it, like F. Definitely want to connect F. You say, yeah, well, F's the one that's farthest to the right anyway. Yeah, but that doesn't really have anything to do with it because there's others. You see E. E has arrows pointing at it, but no arrows leaving it. There's kind of like no way to get out of it if you were traveling along the arrows. That means you want to connect it to the finish. And actually, don't forget C. C has an arrow pointing at it. And otherwise, no way to escape it, so C would also need to be connected to the finish. And this is important for later your calculations coming out correctly. Oh, okay, now we have the structure of the network. We want to know how long this project will take. That was the question. What will be its completion time? We need to do now some calculations. We should at least find the early start, early finish times because that will reveal the answer to that question. So at this point, I am subdividing the tables. I should say the nodes, so they look more like tables. And I want to do something else. I had this, the shape of the network represents the precedence information. I had this other information on duration. I want to add it. We're going to need it. For instance, this fact that A is 2 days long, jot that down right there B is 4 days long, belongs right there. C is 8 days long, belongs right here. D is 1 day long there. E is how long? 6 days? Okay, 6 days. And then F finally is 2 days long, belongs right there. All right, now we're still just getting set up. Because to determine the overall completion time of the project, we should determine its early start and early finish times. What is the earliest we could start and what is the earliest we could possibly be finished with each one of the tasks? How do we do that? We begin at the starting node. We begin at the starting node with noting A, B, and C, each task that's attached to the starting node. What do we note about those tasks? Their early start time is automatically 0. A, early start time 0. B, early start time 0. C, early start time 0. Because 0 numerically is right now. And since they're attached to the start, the option is at the earliest you could start on them right now. Now, to finish this off, let's look at A. 0 plus 2, the earliest I could be finished with A then is in 2 days. 0 plus 4, the earliest I could be finished with B is in 4 days. In the case of C, if I start on it right now and it's 8 days worth of work, I could be finished with it at earliest in 8 days. Okay, then what do? Work our way across the network, across the story of the project, if you will. Because I'm looking here and I notice that D cannot start until A finishes. A will finish at the earliest in 2 days. You can pass that number across then. That means that D could start at the earliest in 2 days, but no earlier. Now D is 1 day worth of work, 2 plus 1, just logic. That means the earliest that we could finish D is in 3 days. I noticed that F, just as long as we're along here, the top of the project, F is waiting on D, right? D, now we know, would finish at the earliest in 3 days. Pass the number across. That means F could start at the earliest in 3 days. 3 plus 2. The early finish time for F is 5 days. Now we need to do this for, there's only one other one we need to do this for. E. But we should be careful. Let's look at this. The network says that E can't start until B and D are finished. I'm just tracing these arrows back here. We now know that B will finish at the earliest in 4 days. D will finish at the earliest in 3 days. The question is that when's the earliest you can start on E, and it can't start till they both finish. You choose the larger of the numbers. Okay, that would be the 4. The early start time for E is 4. That is known as the early start time rule. Technically, we were practicing it in the case of all the other ones, but we just didn't need to articulate it because it was kind of all 1 to 1, just pass the number, pass the number. The early start time rule is the early start time for an activity is the largest of the early finish times of the activities that immediately precede it. The largest. Okay, so if the early start time for E is 4, 4 plus 6, the earliest it could possibly be finished is 10. At this point, we can answer the first part of this scenario. We can answer that question because it's asking what the completion time of the project is. And it's actually on the paper now. You say, well, all right, okay, we were doing early starts and finish times. Where's this completion time? Now that we're done with the early start and early finish time, go to the finishing node. Trace anything that's connecting to the finishing node and look at its early finish time. F could finish at the earliest in 5 days, E could finish at the earliest in 10 days, and C could finish at the earliest in 8 days. They each are going to have to finish in order to declare this is like the grand finish. We're done. Therefore, what is the earliest we would be making that announcement? Pick the largest. Because we'd be waiting on finishing up each of those 3 things. Them being connected to the end means that there are things that will be finished towards the end. There's nothing else that comes after them. All right? And we would be waiting for them all to finish. So when the last one finishes, that's where we get the largest number. So that's actually the answer to the first part of the scenario. That's the completion time of the project. This, right, if it all stays on time, should get done in 10 days. Now, notice there's another question based on this. The other question says, what is the critical path through this project? If the only thing that we needed to know was just the completion time, we'd be done, like as far as numbers, because the only thing we need to find out is those early start, early finish times. If you want to know the critical path through the project, though, you need to find the late start, late finish times. Right, what have we left blank so far? The late start, late finish times. That will reveal the critical path. Oh, all right, no problem. How do you find late start, late finish times? It is the kind of the opposite of what we were just doing. Go to the finishing node. Go to the finishing node and note when you want to finish the project. 10 days. We said we could get it done in 10 days, so we want to get it done in 10 days. Fine. That means anybody connected to the end, that automatically becomes their late finish time. That is the latest we will tolerate finishing them because we do not want to delay the project. All right, we know the late finish time for F, E, and C. Right, and since we know the late finish time, we know the late start time because 10 minus 2 means that the latest we can afford to start on task F is in 8 days. Otherwise, any later than that will cause a delay. 10 minus 6 is 4. The latest we can afford to start on E is in 4 days. And 10 minus 8 is 2. The late start time for C is 2 days. Right. If you have a late finish time, just subtract out the task time and that reveals the late start time. All right, fine. We've done this late start, late finish for 3 of the tasks. What do we do now? We work our way back through the project. All right, working our way back. I am looking at, for instance, E here. I'm looking at the fact that E can't start until B and D finish. I'm just reading the arrows. Okay, E we now know has to start for a fact in 4 days. At the latest, that automatically becomes the deadline for D and B. They'll have to finish at the latest by pass that number back, otherwise they'll cause a delay. All right, so in the case of D, 4 minus 1 is 3. The late start time for D is 3. And in the case of B, 4 minus 4 is 0. The late start time for B is 0, and I'm really relieved to see that, because if I've done late start, late finish times correctly, somebody, at least one task at the starting node is going to zero out. Its late start time is going to be 0. If that doesn't happen, it means I must have messed up the number somewhere. But sure enough, B, it turns out the late start time is 0. What's that mean? It means if you want this done in 10 days, you're going to have to start on B right now at the latest. Oh, okay. Now, keeping with this finding late start, late finish times, there's one last one to do. We haven't done A yet, so let's look at A. Okay, A. Let's see. D cannot start until A is finished, and we now know that D at the absolute latest, D has to start in 3 days. Okay, that means that that is A's deadline. 3. 3 minus 2 is 1. Okay, so at the latest you could start on A in 1 day. The earliest you could start on it is right now, but you could wait as late as 1 day. Okay, that's interesting to know, but what's the question? The question is, what's the critical path through this project? Oh, and I said you needed those things because now they show you the critical path. The critical path is the set of all activities with 0 slack, right? What is slack? Slack's the difference between, for instance, the late start time and the early start time, or the late finish time and the early finish time. Now you can see where the critical path is because you just look for where the timings match. I noticed that for B, they match, and I notice for E, they match. And now I want to check, is that a path? A path is any route from start, yeah, B connects to the start, and then B connects to E to the finish. Yes, that is a complete path. Perfect. That's the answer to the second part of this scenario. The critical path through that particular network is tasks B, E.